In 2014, the city of Flint, Michigan switched its water source to save money. Within months, children started getting sick. Lead levels in their blood skyrocketed, cognitive damage, behavioral problems, lifelong health consequences. Over 100,000 residents were exposed to lead-contaminated water. The crisis made international headlines, government officials went to prison, billions of dollars were allocated for remediation, but here's what they never told you. A plant exists that absorbs lead from contaminated soil in 60 days. It pulls the poison out of the ground and stores it in its leaves. You harvest the plant, dispose of it properly, and the soil is clean. The technology is called phytoremediation. The science has been proven for over 30 years. The cost is pennies compared to conventional cleanup. Cities across America have lead-poisoned soil. Millions of homes, hundreds of thousands of children at risk. The EPA estimates 40% of urban gardens contain dangerous lead levels, and almost no one is planting the solution. For 3 decades, this knowledge has been systematically ignored. Not because it doesn't work, because it works too well for too little money, because you cannot bill millions for a cleanup that costs thousands, because remediation companies cannot profit from plants that anyone can grow. Today, an entire industry depends on keeping soil cleanup expensive. If cities realize that a common plant beats million-dollar excavation, that 60 days beats 60 months, and that seeds beat bulldozers, the remediation business model would collapse. But the truth can't stay buried in poisoned soil forever. In this video, we're uncovering the complete science of Indian mustard, the plant that pulls heavy metals from contaminated ground, the technology that cleaned up Chernobyl, and the solution that cities refuse to use while children keep getting poisoned. By the end, you'll understand why the cheapest cleanup method is rarely used. And you'll know exactly how to detoxify soil that everyone else says requires a fortune to fix. In 1993, researchers at Rutgers University made a discovery that should have revolutionized environmental cleanup. They were testing plants for their ability to absorb heavy metals from soil, lead, cadmium, arsenic, mercury, the poisons that accumulate in urban and industrial land. Most plants absorbed minimal amounts. The metals stayed in the soil. The contamination persisted. Then they tested Indian mustard. The results were so dramatic that researchers repeated the experiment multiple times, certain they had made an error. Indian mustard absorbed lead from soil at rates 10 to 100 times higher than other plants tested. In a single growing season of 60 days, the plant extracted measurable percentages of soil lead contamination. Multiple growing cycles could reduce lead levels below EPA danger thresholds. The plant didn't just tolerate heavy metals. It actively accumulated them. It pulled poisons from the soil and concentrated them in its tissues at levels that would kill most plants instantly. This was a biological vacuum cleaner for toxic soil. The scientific term is hyperaccumulator, plants that absorb metals at rates far exceeding normal biological uptake. Indian mustard was among the most powerful hyperaccumulators ever discovered. The research was published. The findings were verified by laboratories worldwide. The potential was obvious to anyone who read the papers. A solution to soil contamination that cost almost nothing, that required no heavy equipment, that anyone could implement with seeds and water. The remediation industry saw the research too, and they had a very different reaction. Lead contamination isn't a rare problem. It's an epidemic hidden in plain sight. The EPA estimates that 40% of urban residential soils contain lead levels exceeding safety thresholds, not in industrial zones, in backyards, in community gardens, in playgrounds where children put their hands in dirt and then in their mouths. The sources are everywhere. Old house paint contained up to 50% lead by weight. As paint peeled and weathered, lead accumulated in surrounding soil. Every home built before 1978 potentially contaminated its own yard. Leaded gasoline deposited lead along every road in America for 60 years. The soil within 50 feet of major roadways often contains dangerous lead levels. This includes parks, schools, and residential areas along busy streets. Industrial facilities released lead for decades before regulations existed. Smelters, battery plants, and manufacturing operations left contamination that persists today. Even modern sources continue adding lead. Some imported products contain lead. Certain fertilizers and pesticides contain lead. Contaminated fill dirt spreads the problem to new locations. The CDC states that no level of lead exposure is safe for children. Even small amounts cause measurable cognitive damage. IQ reduction, learning disabilities, behavioral problems. An estimated 500,000 American children have blood lead levels requiring medical intervention. Millions more have lower level exposure, causing subtle but real damage. This is the scale of the problem. Millions of contaminated properties, millions of affected children. And a solution that grows from seed in 60 days. Why isn't every contaminated yard covered with Indian mustard? Indian mustard doesn't just grow in contaminated soil. It actively hunts for metals. The roots exude organic acids that dissolve metal compounds bound to soil particles. Metals that were locked in the dirt become available for uptake. The plant literally digests the contamination. Once dissolved, metals are absorbed through root membranes using specialized transport proteins. These proteins evolved to capture essential nutrients, but also grab toxic metals that chemically resemble nutrients. The metals travel through the plant's vascular system to the leaves: lead, cadmium, zinc, copper, arsenic. They accumulate in leaf tissue at concentrations 100 to 1,000 times higher than surrounding soil. A single Indian mustard plant can contain several milligrams of lead. An acre of plants can extract pounds of toxic metals in a single growing season. After 45 to 60 days of growth, the plants are harvested. The contaminated biomass is disposed of as hazardous waste or processed to recover the metals. The soil left behind contains measurably less contamination. Multiple growing cycles, typically 3 to 5 years of repeated planting and harvesting, can reduce soil contamination below regulatory limits. The process has a name: phytoextraction, using plants to extract contaminants from soil. It's not theoretical, it's not experimental. It's proven technology that has been demonstrated at hundreds of sites worldwide. The science is settled. The only question is why it's not being used. Conventional soil remediation is shockingly expensive. Excavation and disposal, the standard approach for lead-contaminated residential soil, costs $150 to $300 per ton of soil removed. A typical residential lot might require removing 100 to 500 tons of soil. That's $15,000 to $150,000 per property. The excavated soil must be replaced with clean fill. More cost. The landscaping must be restored. More cost. The process takes weeks and leaves properties looking like construction zones. Cities and homeowners often simply can't afford it. Contaminated properties remain contaminated because cleanup costs exceed property values. Now consider phytoremediation with Indian mustard. Seeds cost approximately $5 per pound. 1 pound covers roughly 1,000 square feet. A typical residential lot requires $20 to $50 in seeds per growing cycle. Add minimal labor for planting and harvesting. Add disposal costs for contaminated biomass, roughly $50 to $100 per property per cycle. Total cost per growing cycle, under $200. 5 years of treatment, enough to achieve regulatory cleanup levels, under $1,000. Compare $1,000 to $150,000. Compare growing flowers to operating bulldozers. Compare 5 years of gradual improvement to 5 weeks of construction chaos. The math is so lopsided it seems unbelievable. But the math is accurate. Phytoremediation costs 1 to 5% of conventional remediation. Now, you understand why the remediation industry doesn't promote this solution. In 1986, the Chernobyl nuclear reactor exploded, contaminating thousands of square miles with radioactive materials. The cleanup challenge was unprecedented. Radioactive isotopes had infiltrated soil across vast areas. Conventional remediation was physically impossible at that scale. Scientists turned to phytoremediation. Sunflowers were planted on contaminated ponds. Indian mustard was tested on contaminated fields. The plants absorbed radioactive strontium and cesium just as they absorbed lead and cadmium. The results prove that phytoremediation worked even for the most dangerous contamination on Earth. Images of sunflowers growing in Chernobyl's shadow became symbols of nature's resilience. But they were more than symbols. They were functional cleanup systems extracting poison from the environment. The same technology was deployed after the Fukushima disaster in Japan. Again, plants were used to extract radioactive contamination that no other method could efficiently remove. If phytoremediation works for nuclear contamination, it certainly works for lead. The technology has been proven at the most contaminated sites in human history. It has been documented in peer-reviewed research for 3 decades. It has been implemented successfully in dozens of countries. And yet American cities with lead-contaminated soil continue to tell residents that cleanup is unaffordable. The solution exists, it's just not profitable enough to promote. Environmental remediation is a $50 billion annual industry in the United States alone. That money flows to engineering firms, excavation contractors, hazardous waste transporters, and landfill operators. It pays for heavy equipment, specialized labor, and extensive regulatory compliance. These businesses need expensive problems. Their revenue depends on solutions that require substantial investment. A problem solved cheaply is a problem that doesn't generate contracts. Phytoremediation threatens this entire business model. A technology that costs 95% less doesn't generate 95% fewer contracts. It generates 0 contracts. Property owners handle it themselves. Seeds and labor replace engineering and excavation. The industry hasn't openly opposed phytoremediation. They've done something more effective. They've ignored it. Environmental consultants rarely mention phytoremediation as an option. Engineering firms don't include it in remediation proposals. Contractors don't offer plant-based cleanup services. The technology exists in research papers, but rarely in actual practice. It's taught in university courses, but seldom implemented in the field. When asked why, professionals cite limitations. Phytoremediation takes longer than excavation. It only works in the root zone. It requires proper disposal of contaminated plants. These limitations are real but manageable. Time is acceptable when the alternative is no cleanup at all. Depth limitations match most residential contamination profiles. Disposal is straightforward and inexpensive. The limitations don't explain why the technology is nearly invisible. The economics do. Government agencies should promote the most cost-effective solutions. They're supposed to protect public health, not industry profits. Yet the EPA and state environmental agencies have done almost nothing to promote phytoremediation for residential lead contamination. Cleanup guidance focuses on conventional methods. Funding programs support excavation. Technical assistance assumes traditional approaches. Some government research continues. Studies are published. Demonstration projects are occasionally funded. But systematic promotion and implementation support is absent. The reasons are complex, but predictable. Regulatory frameworks were built around conventional remediation. Changing them requires effort that bureaucracies resist. Existing rules specify excavation methods, not planting protocols. Industry lobbying shapes agency priorities. The remediation industry has lobbyists. Seed companies selling Indian mustard do not. Agency staff rotate between government and industry positions, maintaining relationships that favor expensive solutions. Risk aversion dominates government decision-making. New approaches, even proven ones, are viewed as risky. Conventional approaches, even when unaffordable, are viewed as safe. No bureaucrat was ever fired for recommending the standard solution. The result is a system that perpetuates expensive failure rather than adopting affordable success. Millions of contaminated properties remain contaminated. Children continue suffering lead exposure. The solution grows from seed in 60 days, and the government agencies responsible for protecting public health keep recommending solutions no one can afford. Some cities have experimented with phytoremediation. Their results prove the technology works at scale. In 2008, the city of Trenton, New Jersey, planted Indian mustard and sunflowers on lead-contaminated lots. The project demonstrated successful lead extraction at costs far below conventional methods. In Boston, urban gardens have used phytoremediation to clean contaminated soil before food production. Community organizations implemented the technology when city resources were unavailable. In Philadelphia, researchers partnered with community groups to remediate vacant lots using hyperaccumulator plants. The projects improved soil quality while creating green spaces in blighted neighborhoods. In Europe, phytoremediation is more widely accepted. Belgium, Germany, and the Netherlands have implemented plant-based cleanup at numerous sites. The technology is integrated into standard remediation planning. In China, extensive phytoremediation projects address industrial contamination across thousands of acres. The scale demonstrates that plant-based cleanup works beyond small demonstration projects. The pattern is clear. Where phytoremediation is tried, it succeeds. Where it's promoted, communities adopt it. Where it's supported, contamination decreases. The technology doesn't fail, it simply isn't tried. American cities continue funding studies instead of planting plants. They continue claiming cleanup is unaffordable while ignoring affordable solutions. The children growing up on contaminated soil don't need more studies. They need fewer bureaucrats and more mustard seeds. Indian mustard doesn't just absorb lead. It's a broad-spectrum heavy metal accumulator. Cadmium is absorbed even more efficiently than lead. Indian mustard extracts cadmium at rates that make it the preferred plant for cadmium-contaminated sites. Agricultural soils contaminated by fertilizers can be cleaned for food production. Arsenic, the poison of choice for historical murders, accumulates in Indian mustard tissues. Sites contaminated by mining, pesticides, or natural geological sources can be remediated. Zinc and copper, essential in small amounts but toxic in excess, are readily absorbed. Industrial sites and agricultural soils with metal accumulation respond to treatment. Chromium, used in metal plating and leather tanning, is extracted by Indian mustard. Industrial facilities can use the plant for ongoing pollution control. Nickel contamination from various industrial sources also responds to Indian mustard remediation. Smelter sites and manufacturing facilities benefit. The plant is not selective. It accumulates whatever metals are available in the soil. This makes it useful for complex contamination involving multiple metals, which is common at industrial sites. Multi-metal contamination typically makes conventional remediation even more expensive. The same complexity makes phytoremediation more valuable. One plant addresses multiple contaminants simultaneously. The versatility of Indian mustard extends its application far beyond residential lead. Industrial sites, mining operations, agricultural lands, and military facilities all contain contamination that this plant can address. 50 years of industrial pollution cannot be undone overnight, but it can be undone acre by acre, growing cycle by growing cycle, for almost nothing. Recent research has made Indian mustard even more effective. Scientists discovered that adding chelating agents to soil dramatically increases metal uptake. Chelators are compounds that bind to metals and make them more available for plant absorption. EDTA, a common chelating agent, can increase lead absorption by Indian mustard tenfold. A growing cycle that would reduce lead by 5% instead reduces it by 50%. This chelator-enhanced phytoremediation compresses the timeline dramatically. Instead of 5 years of treatment, 1 or 2 years may suffice. The technique requires careful management. Chelators can also mobilize metals into groundwater if applied incorrectly, but proper protocols have been developed and validated. Other enhancements continue emerging from research. Mycorrhizal fungi added to soil increase plant root surface area and metal absorption. Bacterial inoculants enhance metal solubility. Genetic research has identified high-performing plant varieties. Some researchers have developed genetically modified Indian mustard with even higher metal accumulation. While regulatory approval remains limited, the potential for further improvement exists. The technology that already outperforms conventional remediation keeps getting better. Each improvement widens the gap between plant-based cleanup and expensive alternatives. Yet each improvement is published in journals that remediation contractors don't read. The knowledge advances while implementation stagnates. The science has never been the problem. The business model has been the problem all along. You don't need to wait for cities or governments. You can remediate your own contaminated soil now. First, test your soil. Home test kits cost $20 to $40 and indicate whether dangerous lead levels are present. Professional laboratory tests cost $30 to $50 and provide precise measurements. If lead exceeds 400 parts per million, the EPA threshold for bare soil where children play, remediation is recommended. Second, prepare the planting area. Remove existing vegetation, loosen soil to improve root penetration, add compost to support plant growth, but avoid fertilizers that might contain additional metals. Third, plant Indian mustard densely. Broadcast seeds at a rate of 10 to 15 pounds per acre, or about half a pound per 1,000 square feet. Press seeds into soil and water thoroughly. Fourth, maintain the plants for 45 to 60 days. Water during dry periods. The plants are hardy and require little care. Allow them to grow to full size, but harvest before they go to seed. Fifth, harvest the entire plant, including roots. The roots contain concentrated metals and must be removed. Wear gloves during handling as a precaution. Sixth, dispose of plant material properly. Do not compost, do not burn. Bag the material and contact your local hazardous waste facility for disposal options. Most accept contaminated vegetation. Seventh, repeat for multiple growing cycles. Each cycle removes a percentage of soil contamination. Retest soil after 2 or 3 cycles to measure progress. The process is simple enough for any homeowner. The cost is minimal. The results are measurable. You don't need engineers. You don't need contractors. You don't need government approval. You need seeds, water, patience, and the knowledge that authorities have failed to share. These weren't just laboratory discoveries. They were liberation technologies developed by scientists who understood that expensive solutions serve industries, not communities. No excavation contracts needed, no engineering firms required, no 5-figure quotes for problems that seeds can solve. Just biology, patience, and the knowledge that nature cleans what industry poisons. And here's what the remediation industry doesn't want you to understand. This method isn't experimental, it's proven. A properly implemented phytoremediation program cleans soil for pennies while contractors charge dollars. A yard planted with Indian mustard heals itself while neighbors pay fortunes for cleanup they can't afford. Our grandparents would have used plants to solve this problem without being asked. We've been trained to believe only experts can help. Modern homeowners forgot this approach because forgetting made corporations money. Every phytoremediation project rejected is a remediation contract signed. Every contaminated lot left untreated is a future contract waiting. The industry profits from your poisoned soil remaining poisoned until you can pay their price. For 30 years, they've been winning. Contamination has persisted in millions of properties. Children have been exposed to lead that plants could have removed. Communities have suffered health consequences that seeds could have prevented. But knowledge can't stay buried in contaminated soil forever. The science is published. The seeds are available. The method works for anyone willing to plant instead of pay. The next time you see contaminated urban land, 2 futures are possible. One where that soil stays poisoned until someone finds a budget for bulldozers, and one where yellow mustard flowers pull the poison out while everyone watches and learns. If this knowledge matters to you, subscribe now. Share this with everyone living on a contaminated land they can't afford to clean. Because the solution they've been hiding grows from seed in 60 days. I'll see you in the next video.